Welcome to my presentation on wireless communication. The topic is Frequency Division Multiplexing. Myself, Anand Silva Karthik, Department of ECE, Hindustan College of Engineering and Technology. Multiplexing. Multiplexing is a set of techniques that allows simultaneous transmission of multiple signals across a single link, by which maximum bandwidth can be utilized and its efficiency is improved. Multiplexing. Basically, it is classified as frequency division multiplexing, wavelength division multiplexing, and time division multiplexing, where FDM is analog and WDM is analog and time division is digital. Frequency division multiplexing. Three different channels are used for three different data streams. Here it is three input lines. Each data stream is used three different channels by means of three different frequencies. So different frequencies are allocated for each channel and it is demixed in the receiver. The transmitter side. Here you can see three different baseband analog signals, might be a voice signal. It is combined with a carrier signal of three different frequency range, F1, F2 and F3. You can see the range by means of the number of cycles. And this baseband signal is combined with the carrier signal, becomes a modulated one. And finally it is getting combined to a FDM multiplexed signal. At the receiver section, the multiplexed signal is given to three different filters with three different frequencies, and through which we can demodulate the actual baseband signal what we have transmitted. And here comes the example to understand how it is getting multiplexed. So the actual frequency range allocation is 20 to 32. This is what is spectrum. So 20 to 30 kilohertz is our allocated range, and through which we are going to have a transmission of bandwidth 12 kilohertz, whereas each voice channel occupies a bandwidth of 4 kilohertz. So we have to start from 20. So 21, 22, 23, 24, 4 kilohertz. So the first thing occupies 20 to 24, whereas the next channel will occupies 24 to 28, whereas the third voice channel will occupies 28 to 32. So by which three voice channels are utilized in this range 20 to 30 kilohertz. So this is how the frequencies are getting splitted and transmitted. This is for understanding, and this is the diagram point of view for understanding, pictorial way of understanding. Here comes the three different signals. It has to use 4 kilohertz, obviously 20 to 24, 24 to 28, and 28 to 32, whereas the allocator range is 20 to 32. So this is how it is getting multiplexed and it is transmitted, and at the receiver again it is decoded or demodulated by means of band pass filters with the specific range. Example 2. Example 2 is God band. So if there is 100 kilohertz bandwidth or to be multiplexed together, what is the minimum bandwidth utilized by this particular thing? For example, if there is 5 channel, each of 100 kilohertz, so 5 into 100, 500 plus. In between each channel, we have to insert one God band. It is of 10. So 5 into 100 plus 4 into 10, which is 540. And here it is easily understand. So we are having 500 kilohertz voice channel, and each has to be separated by means of a God band of 10 kilohertz. So totally 100 into 5, 500 plus 10 into 440. So total bandwidth is 540. Next is about the modulation required. 4 data channels, each transmitting at 1 Mbps and uses a satellite channel of 1 MHz, whereas 4 data channel is digital and this satellite channel of by default it is analog. So the solution is the satellite channel is analog and we divide into 4 channels, each having 20 kilohertz bandwidth. So each channel of 1 Mbps is modulated such that each 4 bits is modulated to 1 Hz. So from this, the one assumption is 16 QAM can be most commonly used, and this is the diagrammatic representation of the above problem. So 1 Mbps digital channel of 4, and each 16 QAM has used the 250 kilohertz as bandwidth. So this is how the frequency is getting utilized by means of frequency division multiplexing. Why I'm saying is this frequency is the important parameter in the upcoming generation, that is in 5G and 6G, by means of reconfigurable intelligent surface, which is the predominant one in 5th generation and 6th generation, where if this particular end user wants to utilize a frequency range of 20 kilohertz, where this particular end user is suppose transmitting at 10 kilohertz, it's supposed to convert this received 10 kilohertz into 20 kilohertz, and it will be transmitting towards this end user. So this is called as a reconfigurable intelligent surface based on the availability of bandwidth in this surface. So based on the availability of bandwidth, it can able to reconfigure the frequency range to the end user and for multiple operations. So this plays a vital role in 5G and 6G. The predominant factor is frequency. So frequency is one of the predominant factor in wireless communication. Thanks for watching my presentation.